be doing a fireside chat with Tom Mueller, who's the founder and CEO of Impulse Space, an exciting new company in our sector. So we're going to be sort of delving into a little bit about that, and then we'll open it out for questions. Tom, firstly, nice to see you here at Satellite. Have you had a good show?
Great to be here.
Given your background at SpaceX, there is perhaps a little bit more hype around Impulse Space than other similar type companies. What do you think makes Impulse Space unique, and how would you quantify the scale of ambition of your company?
Well, I think, we had, I think just the team that I have, myself and my team developed, the propulsion systems for the Falcon 9. And also for Starship, Raptor. So we're talking about some of the most reliable and sophisticated propulsion systems, in existence. So I think, that's the main part of the hype around my company. I think just a proven team that's delivered, and we have the capability of doing high energy, high performance chemical propulsion. So I think within the market that we're in, we're looking at doing definitely the higher end of capability, adding more impulse or more delta V to large vehicles than anybody else is talking to. So I think that's our niche.
All right.
And as far as our, what was this, the last part of that?
About quantify like the scale of ambition of the company.
Yeah, I think that's the ambition, is just to be able to deliver payloads to anywhere in the solar system. It's well beyond Earth orbits. Like we're working on high energy systems to go anywhere, to really get the space economy kicked into high gear.
Okay, what are some of the key milestones on the road to profitability for Impulse Space? Because it is an ambitious project, and it's not.
Yeah.
It's not easy either. So
right.
what are sort of the key milestones to get to?
Well, we started out with a smaller vehicle, the Mira, which is flying right now. So something I often say it's kind of like SpaceX did a Falcon 1 first to learn on a smaller vehicle, make their mistakes on a smaller vehicle. So we started with the Mira with storable propellants, bipropellant engines. And learn how to operate a vehicle in space. Learn about the guidance and control. The propulsion system worked well as we expected, but we still had a lot to learn on the avionics, guidance systems, the thermal effects in space, microgravity effects, especially on propellant in the tanks, things like that. So we're learning on a simpler vehicle that all these things we can apply to the Helios vehicle, which is our next one. And on that one, it's just going through the steps, like engine testing. This year's all about development. So engine testing, full engine testing this summer, a development tank by the end of the year. Next year's all about qualification of the engine and the tanks and development of the other systems like the avionics and the valves and things like that, with stage testing by the end of next year. And and then a wet dress rehearsal and getting into our demo flight of Helios in early 26.
So a big couple of years ahead.
Yeah, it's really getting exciting.
We interview a lot of, sort of startup companies looking to make an impact in this sector. One of the things I'm always very keen on talking about are actual contracts. The lifeblood, where the revenue is going to come from. In terms of commercial contracts, what is sort of the roadmap looking like for Impulse Space over the next couple of years, and when do you expect to sort of make breakthroughs in that regard?
Well, we're happy to say that after flying Mira, which is flying right now, we've got a couple more of those, one this year and a couple possibly next year, and that manifest is filling up. We've already announced Helios as one of our customers. There's several others that we're going to be announcing pretty soon. So that's like an existing product line that we've already established. But our main business is going to be Helios, which our first commercial flight of that is in the second half of 26. So it's still more than 24 months out. So it's a little early for the GEO and MEO customers to sign, but I can say this: there's a lot of interest in that vehicle because of the basically the economics that it offers, or the ability to get to your orbit in a day, from low Earth orbit to GEO. So I think we have some customers that are going to fill out already that first commercial flight. I think we have some possibilities for signing for that first commercial flight in late 26, and we also have a few that are talking about the 27, filling out the 27 flight manifest. So it's looking good. It's
exciting to hear. I mean, I don't know how much more you can share, but sort of the types of customers. I mean, who are sort of what types of customers are showing?
Mostly the names that we know that do GEO and MEO operations.
Okay.
Yeah.
Okay. I mean, you touched upon it there. I had a question about your hopes and aspirations of the Helios vehicle, and talk about the significance of that for Impulse Space.
Yeah, Helios is going to be our prime mover. You know, it's the engine for it is a 15,000 pound thrust LOX methane engine, which we kind of feel is going to become the oil of space. With Starship hopefully putting propellant depots in space. So, and most of the new vehicles using that propellant, so it's easier for us to load that propellant in the fairing of the new vehicles. It's just an exciting opportunity to really, I think, make a big difference for operators right now. And it's already a tough market because LEO is really, everybody's talking about the LEO constellations right now, and it's made it a pretty tough market for GEO. So now we're going to greatly reduce the cost of access to GEO, and certainly improve the speed of getting there. Taking out that 6 to 10 months of transfer time from GTO to GEO, and that loss of revenue. So there's a lot of interest in it, and we're pretty excited about it. And then beyond that, once we have filled out and start entering this GEO market, I'm pretty excited about the things it can do in the future. With like say lunar activities and going to outer bodies. So a true space economy.
I'm going to get to the space economy in a little bit. I just want to go back a little bit, because one of the big themes of this event has been, in some ways, the future of GEO and how it mixes with other orbits. Obviously, we've had a lot of the big operators talk about that. We'll talk about these hybrid strategies and using multiple orbits. As someone that's maybe looking at it from a slightly different perspective, or comes at it from a different angle, what's your take on how this future is going to look like?
We're seeing a lot of the mini micro GEOs come in, and we're talking about almost like a ride share on Helios to GEOs. It's really hard for a small satellite to get to GEO right now because the ride shares are so few and far between. What we'd like to do is stack ESPA rings on Helios, and we can take the small guys up there pretty much all at once. So that's something that we're talking quite a bit about.
Okay. What have been your sort of key takeaways from the LEO Express One experience?
We learned a lot. We first of all that everything worked. We were sun pointing and power positive, and thank God it's alive. We actually got to do a debris avoidance maneuver within a couple months of being up there, so that came a little sooner than we expected, and we're able to successfully dodge some space debris. But mainly, doing the demonstration burns on this got 8 thrusters on it, 8 bipropellant thrusters, doing the orbital changes and plane changes that we've done so far, getting that data back, verifying that our guidance and control systems are working well, and working out, finding out how difficult it is to get these radios working with the ground stations, and finding out that not every ground station is the same. Some work, some don't. There's a lot to learn there that we're still learning on, but so far it's been very successful.
Okay, great. I did want to talk a little bit about the space economy, because there's all kinds of themes at this event, as I'm sure everyone knows here, and I know the future of the space economy is something that's talked about sort of quite a lot. Do you think it might take off a little bit slower than a lot of experts think here? And what do you see as the future of the space?
Yeah, we're here to help speed it up. I think access to low Earth orbit has vastly improved, over the last 20 years, and another huge step is about to happen with a fully reusable Starship flying often. Basically, consider access to LEO solved, but it's still difficult to get from LEO anywhere else. It's expensive and there's not a lot of options. We want to provide those options. We want to do for all the orbits, the high energy orbits above LEO, what SpaceX and others have done from Earth to LEO, and really make it easy to do the things that people want to do in space, whether it be in Earth orbit or on the moon or to the asteroids or to Mars. We're game to help do any of that.
No, super interesting. I'm also curious, given your background, why you sort of decided to focus on sort of like the in-space transit when there's usually so much more attention on launchers, landers, and satellites. So I'm sort of curious as to your sort of thinking and your vision for doing.
We're a propulsion-centric group mostly, myself especially. So for me, I was looking at in my last years at SpaceX, I worked almost solely on Starship, and just realizing that it's going to bring 100 tons to 100 plus now, 100 tons to low Earth orbit every time it flies, and just for me realizing there's the opportunity is to move those things around, because when 100 tons goes up, it's not necessarily going to be one 100-ton piece. There's going to be probably a lot of things that need to go to different orbits. So that was the natural extension for me, was to be the group to provide that transport, beyond LEO.
And I'm just sort of curious. I mean, how did the SpaceX experience sort of benefit and sort of like really influence what you're doing now?
Oh, a very strong influence. We want to run basically a small team of very dedicated individuals, very close, keep the engineering very close to the hardware and to the testing, make the engineers responsible for their product, what we call a responsible engineer that carries their system from cradle to grave. Basically being very vertically integrated, which means we basically make everything ourselves: the avionics, the valves, the thrusters, the tanks, the structure. So extreme vertical integration. All the things that we learned at SpaceX that worked well for SpaceX.
Okay. I'm going to open it up in a couple of minutes for questions. So if you have questions for Tom, we'll start getting to those. In terms of funding, you've announced a number of funding rounds recently. Where are you in terms of the funding cycle?
Yeah, last summer we closed our A round. We raised $45 million for that round. We'll be doing our B round later this year. So I think we got some excitement because I think we have a pretty good business plan right now. So hopefully things go well on this. The first two rounds, the seed round and the A round, went quite well for us. Both were oversubscribed. So hopefully that happens again.
Excellent. Let's start opening it out for questions. Do we have any questions?
First of all, thank you so much for your contributions to our industry. I don't think many of us would be here today if it wasn't for your early work. Are you at liberty to say what the biggest challenges are in propellant transfer in space? Thank you.
Yeah, propellant transfer is, I think, extremely important, especially to get where I want to see space get to. In order to have reusable vehicles in space, you need propellant depots in space. Basically, just think about gas stations throughout the inner solar system so that we can work in space and reuse the vehicles that we have up there. I'm excited about the Artemis and the SpaceX HLS program where they're going to be doing propellant transfer and hopefully eventually propellant depots in space. Luckily using the same propellants we are. So I think I've said publicly before, Starship needs 1,500 tons of propellant. We need 13 tons. Please give us a SIP, and then we can keep our vehicle up there and moving around in space. So it's super important. And certainly the government uses of maybe the storable propellants in LEO and in GEO is important, and we have contracts to do that also. So yeah, I think that just like reusability is the future of launch, I think reusability with propellant transfer is also the future of in space.
Do you have any more questions?
Sorry, I know it's tacky to ask questions at my own conference, but I can't help it. Tom, we had a session here earlier about the future of propulsion beyond fuel. I was just wondering what your thoughts were on some of the alternative propellants that have been proposed from maybe other startups, other companies.
I like completely non-toxic propellants, like truly non-toxic. Our propellants for Mira are nitrous oxide and ethane. We're running 295 seconds of ISP in a 5-pounder, and possibly about 310 in a 180 pounder. It's just the cost. You eliminate the cost of safety, which drives up huge cost in other propellants, like even things that are considered non-toxic compared to hydrazine, like peroxide or Ascent are not completely non-toxic. I just think with the reductions of costs that we're seeing on access to LEO and the reductions of costs that we want to bring to everywhere else, these propellants that cost hundreds of dollars per kilogram, or and take a lot of time to process, are going to get priced out of the market. That's why we headed towards just a propellant that's completely non-toxic that we can run in our right in our shop as far as our storable propellant, and then also with LOX and methane, really the cheapest propellant for high energy that there is. The lowest cost form of hydrocarbon fuel and liquid oxygen, which is of course very, very low cost. So that's where we headed, and I think it's the right choice.
Thank you.
Okay. One.
Hi, I'm Torkel Mogstad. Was it ever an option to do impulse space stuff as part of SpaceX?
There was a lot of talk about doing kick stages at SpaceX throughout the years, even I think more recently. It's just the prize was always Mars, and this was something that was never high priority, so it didn't happen, which left an awesome opportunity for my company.
So you mentioned Mars, and it's nice to see you, Tom. Thank you. I attended a conference in 2006 where Sir Richard Branson talked about flying to Mars on April Fool's Day. It was a joke, by the way. He recruited a bunch of folks to come up on the stage to fly to Mars with him. It was a prank. How do you feel about that? Is it real? Is it something we can achieve in our working or living lifetime?
Absolutely. I think I don't know how long it's going to take to colonize Mars, but certainly exploration of Mars, humans on Mars, is going to happen, I think, pretty soon, especially with the progress that's being made on Starship. And we're excited about doing missions to Mars. Like the first mission that we signed was with Relativity to do a Mars lander. So we're looking at landers for both lunar and Mars, and I think we can offer a much lower cost alternative to take payloads to Mars, and hopefully someday even to be able to bring things back. We would love to do that. Yeah, we're excited about Mars.
Great questions. Do we have any more? Okay, I've got one or two more while let's see if anyone else comes up with any questions. What is sort of the international play for Impulse Space? I mean, will most of the initial customers that you're looking at come from the US?
It's been a mix. I would say for Mira, for the LEO stuff, it's been mostly US, but some international customers for, then I'd say for Helios with the big GEO, you know, these are global companies. I think they've been mostly non-US or a combination of US and global customers. Yeah.
I mean, following on from that, one of the big themes of this event and other events that we do has been the strength of like the government customers, and particularly as there's an increase in defense spending at the moment.
Yeah.
Is it ultimately customers like the Space Force, for example, that will be the ones that drive the in-orbit logistics and space transportation market?
Yeah, we have a couple of TAC-RS SBIRs, both one for Mira and one for Helios. And you know, right now the Space Force and the government are speaking our language. You know, sustained space maneuvering and dynamic space operations. That's what we're all about. So it's taken a while to get on track to these programs. Luckily for us, there's an immediately addressable commercial market that we're going after first. But I think there's going to be a lot, you know, from 27 and beyond. There's going to be a lot more government interaction for our products. Both, you know, we're doing a GEO capable version of Mira for our orbit fab, for our orbit fab contract, and I think there's a lot of interest in that. And then of course Helios, getting the government. You know, commercial operators typically will go to GTO, and the way we help them is we just eliminate the GTO and that long transfer time. Government typically will buy like a heavy, so for them we're just offering a much, you know, able to fly on a single stick Falcon 9 with Helios, and just cutting out a lot of cost and a lot of operational difficulty. And so in both ways we're helping government.
Okay. Over the last year, we've seen how difficult it is to launch rockets. I mean, what happened with Virgin Orbit is a little bit of a cautionary tale.
Yeah. We have constant reminders of how difficult space is, don't we?
Does the same apply really for like the in-space transit market as well?
Yeah, so for Helios, you know, we're putting an upper stage on the most reliable rocket in history. I think it's pretty clear that, you know, SpaceX the Falcon 9 has flown over 300 times without failure. The place that they're doing this, the fueling of our propellants is on the only human-rated pad in the Western Hemisphere. So we are very aware of the importance of reliability. And that's why we have a pretty long development and qualification schedule, just to make sure that we have a super reliable product. And I think a team that has demonstrated reliability. I think a lot of the success of Falcon 9 is due to the extreme reliability of the Merlin engine and that propulsion system, which I'm quite proud of. So I want to continue that heritage into our new products.
And I mean, in-orbit logistics services, refueling satellites has been, again, a lot of these topics we've been talking about for quite a few years. They're not necessarily new topics.
Right.
When are they going to become mainstream?
The time is now. You know, with the orbit fab demonstration of a fuel transfer in GEO, that's kind of getting that activity started, and certainly these Artemis refueling. Big refueling of cryopropellants. I think now it's going to really start to accelerate.
Okay, I'm going to do like a final call for questions before I wrap up. Okay, one here.
Are you interested in the small scientific satellite market at all?
In the small what?
Scientific?
Science satellites. I know a lot of customers that are really hungry to get there. They're not commercial, they're not going to make money.
Yeah, the things I'm really excited about is exploration of the outer planets and stuff. And I've said, you know, the Helios stage, you know, with 13 tons of propellant and a very lightweight stage with a, you know, very high performance engine on it, can do about 10 kilometers per second of delta V empty. So with a, you know, say a half-ton science mission, we could save years on a outer planets mission. So, and for a very low cost. So I'd be really excited about going on a, you know, one of the current vehicles as a third stage and really reduce the cost and get the science much sooner with Helios as a stage. Yeah.
Okay. What? Just want to.
Given the cost reductions that you were just talking about for sending missions to the outer planets, do you think there's ever a case for using any more esoteric propulsion technologies like electric or nuclear-based propulsion?
Yeah, definitely electric is in our future. I think we're going to need an electric solution at some point, EP. I was just talking to some of the EP vendors here at this event. I've looked at, you know, the Mira vehicle with our storable bipropellants can do, you know, on the order of 1.5 kilometers per second with a small payload. If we converted those tanks to Krypton and put, you know, a Hall effect thruster on a Mira, now we can talk. We're talking about doing 4 to 6 kilometers per second, which enables, you know, missions to asteroids and things like that. Nuclear is out there a ways. Maybe I'm a little late in my career for that, but I definitely want to see that happen. And maybe my company someday, the people that carry my company forward will develop that. I'd be very proud of that.
One last question.
Just to pick up on reliability you were mentioning and refueling, can you talk a little bit more about how often do you plan to maybe refuel the vehicle that you have then in space? What sort of like lifetime you're imagining?
Yeah, refueling's not in the current generation of the vehicle. That's something that will come later. I think this is going to take a while. Just like SpaceX was an expendable rocket for a while until we developed the reusability. That's something that once we're successful in flying a lot, and I don't know that we're going to develop those propellant depots. I hope we don't have to. We'd love to do it if we had to, but hopefully there will be propellant depots that exist out there and we can get use of them. Then I think we would be very strongly inclined to make like Helios reusable or Mira also, especially like in GEO. Like once you get a Mira up to GEO, there's, you know, there's so much spent to get that asset there. It's a shame to just use it for a while and then it runs out of fuel to throw it away. So it's easy to have a propellant depot in GEO because it's a single orbit. So it's just, you know, in LEO there's so many orbits it's hard to make depots work, but in GEO it's almost a no-brainer.
And just final question, Tom, just to wrap up. What does the next chapter for Impulse Space look like?
Well, the chapter up till now has been mostly Mira, but the next chapter is certainly all about Helios, getting through the development testing this year and the qualification next year in 25, and then flying in 26, and flying a bunch of them in 27, and then look at like the next development that we want to do. And hopefully, what I really want to see is this refueling, is manufacturing in space, is using the resources, the lunar resources, you know, the water that's on the moon, the minerals that are on the moon, you know, silica on the moon, so that you have a true space economy that's using the resources that are in space to offload the use of resources from Earth.
Excellent. Well, we're literally just out of time. Tom.
12 seconds left.
12 seconds. We managed to I can probably talk for another 6 seconds, but may not want to hear that. But Tom, it's been an absolute pleasure. We wish you and Impulse Space the best of luck. It's such an ambitious company, and we're going to keep a close eye on you on the years ahead. We wish you all the best. I think you're going to do amazing work. Let's give Tom a big round of applause. Thank you. Thank you.